actually start this as well. All right, we're back. We are COMP123. That's programming 2 in the summer 2017 semester at Centennial. And we are lesson 11, part 1 of our broadcast. We're going to be talking about intro to LINQ, whatever that is. Let's talk about what that is today, as well as collections. We're going to talk about collections, and of course, we're going to be talking about the list collection in more detail today. All right, cool. Let's get right to it. We have a busy day. One thing I'd like to mention is that I did finish up marking your labs, and I caught all kinds of cheaters. I'll tell you right now, although I didn't give them 0, right? I got to say that it was very easy to catch them because they were the exact same code from one person to the other. I mean, the exact same code, even the exact same errors, right? And that is like stupid. If you're going to be a thief, be a good thief is my message to you, right? If it happens again, and if I see you guys, you know who you are, cheating, and that means like on your assignment, you'll get 0. And if I see it one more time, I'll have to ask the associate dean or the chair to kick you out. And that would be very, very bad. That'd be a very bad outcome for you in this semester. All right? So please don't cheat. That's not worth it. What do they say? Don't do drugs. Don't cheat. I don't know. So what we're going to be talking about today is LINQ and the list collection in more detail. And I'm going to use a PowerPoint for some of the slides that I'm going to start off with, right? But basically today, this PowerPoint is up on eCentennial, by the way. We're going to be talking about what LINQ is. And last day when we were together, we made this very bad search algorithm for our superhero class, where we found the powers of the superhero in a very linear order. And yes, it's only 4 or 5 powers, so it might have been okay. But what if it was a list of 1,000? That'd be really, really inefficient. And I'm going to show you ways of finding that information a lot quicker. So what is the difference? A list is like an array, but it's got a dynamic size to it. It can be sized. It has different capacity, right? One thing I want you to look at, for example, is this idea of SQL or this idea of a query language are used. Now, you guys are taking database now, yeah? Anybody? You guys are all taking database? So you guys have access to SQL, right? SQL, which is a type of query language that allows you to query the database, right? Well, Microsoft built their own query language to SQL, to query other data types or other data sources, including lists and arrays and anything else you want, even integers, weird stuff like that, it's called LINQ, Language Integrated Query Language. That's what it is. It's LINQ. And we use it. It's very, very simple, but it matches very closely to what SQL looks like, okay? So let's skip through this. So there's 2 types of ways we can see LINQ. And by the way, LINQ is going to be covered in much more detail in Programming 3, where you'll be talking about lambda expressions, right? Remember, I briefly touched on lambda expression when I was talking last week, when we were talking about different kinds of enumeration functions, right? So we're not going to be talking about that today, but LINQ is going to be covered again, like I said, in Programming 3, where they'll be talking about the method call syntax. This is the method call syntax, right? So there's 2 syntaxes for LINQ, the SQL-like syntax, which we're going to be covering today, and then the method call syntax, which we'll be covering in Programming 3. And I'm not sure, I don't think you have Programming 3 next semester, right? I think it's in 2 semesters. Yeah, so like 2 more semesters. All right, so what is LINQ? Well, LINQ is it's an imperative programming methodology, right, that allows us to do something like this. Okay, first of all, for us to use LINQ, we need to have it's a big library, so we have to bring it in into our programs by this using statement, using system.linq, and you'll notice when you actually create any class, it's included. But by chance, if you're programming on your own, or if you're using some other IDE other than Visual Studio for whatever reason, you could or you may need to include LINQ to use it. So Visual Studio 2015 and later 2017 actually includes LINQ in all of your classes. All right, but this is what it looks like here. Take a look. From, where, select. This is exactly like SQL, right? Well, kind of. And why? Because Microsoft wanted to match what we already know when it comes to database management here in our code, right? And make it easy for us to use queries or create queries that query data, right? Because application without data is like no application. We always use data somehow, right? So here's how it works. From, think about from as a for each loop. That's the portion of that. So we're just going to say like from our, we just use powers, from power, from the power in the powers table, powers list, right? Where, let's say my power rank is greater than a certain number, select that power. So return, so select is like return whatever matches up here in the from and where. Where is their conditional? From is the collection or the data source we're looking at, and select it is the return value. And I want you to look at this variable up here with the var in front of it. Again, think about var as implicit typing, right? And filtered would then be a list of values. That's what it would return. That's going to be returned from this query. Okay. So here's a sorted list. So from our value and values, order by whatever value we find, right? The value itself, right? So maybe this could be in alphabetical order, as an example. In ascending order, that's what we're going to do. We'll return that value in this list. That's what's going to happen. Okay? That's cool. I like that. And of course, when we write it out, we're going to go through a for each loop. And what we're going through a for each loop with this sorted variable. Well, the sorted variable is like a list, yeah? That's how we're treating it. If we can do a for each loop, then it's a collection of elements that we're returning from these three things here, from order by and select, or like it said previously, from where and select, right? So think about the from again, if I was going to reiterate, as a for each loop, kind of going through each of the elements in your collection or your data source, right? And the where clause as some kind of conditional statement. The order by allows us to order the list that we're getting back in a specific way. And the select is what returns, the values that return. Okay. Now there's some options here. For example, you can order by descending. That's a keyword you can use. By default, it's ascending by default. So it goes alphabetically from the lowest to the greatest. But you can go from the the greatest to the lowest, or reverse alphabetical order if you're alphabetizing. And you can also use where and the order by all in one. So here's a clause, a more complicated query, where you're saying from this value in values, where the value is greater than 4, order by this value in descending order, right? So let's say I want a value between 4 and 10, right? As an example, then it'll start counting if it's descending as 10, 9, 8, 7, 6, 5, 4, right? Or 5, actually, because 5 is greater than 4. And there's an array of the stuff that it'll return. Nice. Very, very simple. So really, you need a from clause. That's the first thing. So from whatever the object that you want to define as, from my card in cards, from my power in powers, from my item in list, whatever you want to call it, right? That's what the from does. It's the for each loop. It's that for each loop that runs through everything. And then you need some kind of where clause, where there's some kind of thing you're looking for, where my ID is equal to student ID, where my power is equal to my power ID, where my whatever you're looking for, right? That's what the where clause is, right? And then my select clause will be the bare minimum you need. You can use the order by too, but select those three things you definitely need: a from, a where, and a select. Okay, where my thing, and then select basically returns everything. Okay, that's what my select does. Now you can also have the order by like we talked about, and by default it's ascending, but you could use the descending keyword to return everything in reverse order. Now we're not, this is assuming that the list is in alphabetical order. Okay, if it's not in alphabetical order, the results will be in the first ascending order that it finds. So if it finds, like, if you try ascending as an example, or if you return by order by a certain way, it'll assume that you've already sorted the list. It won't sort it for you. So the way to do it, of course, is to sort the list first. Sort the list before you use the query, and then it'll come in sorted order. One thing we have to also consider is that whatever the LINQ returns, All right. And I want you to think about, remember we talked about interfaces last week and the week before. Arrays and collections of all types, lists included, implement the IEnumerable interface, which means they have an enumerator, an index. That's what an enumerator is, right? And so too does LINQ. LINQ returns an object that implements the type IEnumerable, which means chances are it's going to return a list or a collection of stuff that matches the query that you're running. That's what's happening, okay? So again, you don't have to limit it to arrays and simple types. You can use it with other complex types, like, for example, our own classes and objects. And sometimes what you want to do is you want to use this IComparable, order by, uses IComparable to compare one item to the next to make sure that you can see what's greater than or less than. And it uses the same IComparable interface to compare when we use the where clause to say where this item is greater than this other item, okay? And again, you can implement the IComparable interface in your class so that you can compare one item with the other. We did that last day when we overloaded the greater than and less than operators. And you can use that so that the where clause can detect which one is greater than which one is less than, which is kind of cool. That's why I did the greater than, less than, right? And again, you could, IComparable and IEnumerable are the two interfaces, like I said, that are some of the most common. Okay, so here's an example. I've got an employee class. Here's an employee class. And the employee has three properties, actually two properties, and what looks like a private instance variable called monthly salary. Okay, so first name, last name, monthly salary. Yay. I have a public constructor that takes the first name, last name, and monthly salary. It initializes them right here. Okay, and that's all the employee class does. Cool. And here's my monthly salary public property. So I have a public interface to my private property, which is cool. That's good. So public property, private instance variable. Okay. And here I'm overriding the toString method. We're going to do that today. And I'm returning the first name, the last name, and the monthly salary. That's what I'm doing here. Okay. Great. That's my employee class. Wonderful. Now, here is my main driver class. And what I'm doing is I'm creating a new list, a new array called employees. Notice I'm using the new and then less open square bracket, close square bracket. And I'm using initializer syntax here for the array. So I'm adding a bunch of anonymous employee objects into my array. Each of the elements in my array is going to be an anonymous employee object. Okay. I think this is better suited as a list. We're going to be talking about that today. But you can certainly do your initialization of an array like this. Okay. Fantastic. So there's a bunch of different objects inside of my array. Great. Now, I want to use this new variable called between 4K and 6K, where I want to search through my array, and I only want to return a list of employees that have greater than or equal to 4,000 monthly salary or less than 6,000 monthly salary. Those are the only ones I want to return. Remember what we did last time? I wanted to return, I had to search through the ranks to find which power was there, if it was there at all. And I made this really ugly search function, like I said in our powers list, but I could have just done this with LINQ. So from E, now I would never name it E in my programs, but from E would be like employee. For every employee and employees, loop through each of the employees where the monthly salary is greater than 4,000 and less than 6,000. Return a list of those employees and store them in this variable called between 4K and 6K, which is now a list. So it's a list of elements that match the criteria. Okay, cool. And now I can write them out. All right, I'm writing them out, and I'm writing them out in a for loop. I'm going through the entire I'm using a for loop to cycle through this new list between 4K and 6K and output them to the console. Make sense? So that's a great example of how to use LINQ with a collection, an array. Okay. And if you notice, I can do it again. But here's something that I want you to think about. With this query, I can write the query, but the query won't be executed until I use it. Okay, let's absorb this, what I'm saying here. It's called deferred execution, okay? So I can write a query, but think about it as an event. I'm creating an event, right? And the event is going to be triggered when I execute it. Here, it's just, I'm just creating the query, but it's not executed until I do something like this, until I put it inside of, until I compare it or put it inside of some kind of loop. When I'm actually using the query, the results of the query, that's when it gets executed. Okay, deferred execution. That's how it works. So even though I wrote it up here, nothing's happening yet. This name sorted has nothing inside of it. It only works when I call it, when I'm actually using it like here. Let's go back and look at this. So this between 4K and 6K, this variable that we're creating right now is empty, even though I've written it. But as soon as I loop through like this, it executes. It's called deferred execution. It doesn't execute immediately like we normally are used to. Okay? So concepts that are new. Okay, so what the hell is this? We did this same thing. So for every employee and employees, order by e.lastname, employee last name, and employee first name. Notice there's a comma between the two. So I can order not just by ascending and descending, but by specific elements or properties of my object. My employee is an object. I'm going to sort by last name first and then first name last. And it's going to be done by default in ascending order, right? And then I'm going to return a list like that and store it in name sorted. This object name sorted is going to be a list with all the elements that match my criteria, right? Notice here, if name sorted.any, what does this mean? .any method says that, does it return anything? Because maybe whatever I asked for here doesn't return anything. So .any would be false if that was the case. If it matched something, then .any would be true, and then we would run this, console write line, the first one. So name sorted.first, the first method returns the first element of the list that's inside of this name sorted variable. All right, so a couple more methods here, any and first. Any, again, checks to see if there's any match. And first returns only the first element in the list. That's what it does. So again, really some real quick shortcuts to help you guys. Here's another one. Okay, so here's my last names. From employee and employees, select only the last name, employee.last name. Now, in this case, my last names list is a list, but it's a list of last names. It's not a list of employees anymore. That means it's a string list, right? Why? Because last name is a string, and it's returning every last name, not the employee. Notice that it says employee.last name. I'm not returning employee anymore like I did here, right? Here's the employee. I'm returning the last name only, which is a string. So this last name is a list of strings, right? And notice that I'm using the distinct method. So I'm saying, hey, don't give me all the last names. If I have 5 Patels or 4 Smiths, I only want 1 Patel and 1 Smith in the list of last names, right? So it gives me the distinct name, almost only one, a unique name for each of them that we find. So if there's, I don't know, 25 unique last names, but there's a bunch of duplicates, we don't care about the duplicates. All right, here's one more. So here's our names. And now this is something you've never seen before, right? From the employees list, I want to create a new object from the employees that I find. So I'm going to create a new list of names. That's what I'm doing. And this list of names is going to not be an employee list anymore, which doesn't exist, right? I'm using the new keyword to create a new anonymous object type, right? A new anonymous class, basically, is what I'm doing, right? That has 2 properties, first name and last name. And I'm storing those 2 things inside my names variable, right? And that names variable is going to be a list of this anonymous type, which is that has 2 properties, first name, last name. Okay, so again, a bunch of concepts that they introduce you all at once, right? But they're really useful. Okay, let's look at the output now. So the output looks like this. The original list, this is what the original list outputs, right? And notice that by default, it does it in ascending order, right? Red, green, indigo, blue. And notice that this is not sorted, right? Not sorted, okay? Jason, Ashley, Matthew, James, and all that stuff. But all we're caring about is numbers, salaries that are greater than 4,000 and less than 6,000. or I think is less than 9,000 or something like that. This is the entire list. Here's only 4,000 to 6,000 right here. I'll be okay, right? And this is the first name, right, of the employee when sorted by name. Only the first one, okay? And here's the employee, the unique list of employees that we got with a distinct method, right? Here it is right here. And then here's the names only, first name and last name. And these are unique objects that we're returning. So how does this all work? Well, again, the where clause, it just doesn't have to be one conditional statement. You can use the double and ampersand sign to have more than one conditional statement, like where the salary is between this and this, use the double ampersand sign, okay? And here's the other stuff. Our order by clause can have multiple resorts as long as you comma separate them, like we did with first name and last name. You can order first by last name and then by first name, right? So you're ordering by that alphabetical order. And then, of course, you have these two methods, any, first, right? And of course, you can use the count method because most times it returns an IEnumerable type. That's what the type that LINQ returns, IEnumerable, right? So it means it returns a list, right? And if I use the any method returns true if at least one element is found, false if there's no elements that found, right? And the first method returns only the first element that's in the result, right? Which is kind of cool. So really quick ways of getting to the data. And that's the biggest problem we have, right? We have a bunch of data in a list, but we want to get to that data, and it's really hard to do that. All right, so here's a couple of properties. This distinct method only returns non-duplicate values, right? So unique elements from the list. Distinct. And this method here, when we use this anonymous, the new keyword, creates an anonymous object that has two elements, first name, or two properties, first name and last name, right? But this is an anonymous object. We don't have a class for this. Typically, I wouldn't do this. But sometimes, if you want to be quick and dirty, and we don't want to create a custom class, we can do it right like this. And we can return a list that has a subset of the original list. Because remember, our employee list has, we can't return an employee because an employee has first name, last name, and salary. And we don't care about the salary. All we care about is first name and last name. So we need to create a new, almost like a subclass or a derived class, right? And that's a real waste of time. Okay, so that's kind of some really cool things with LINQ, right? And I'm not going to talk too much about this because I want to get to collections. Okay, and that's all I'm going to talk about this today. And then next day, we're going to be talking about the list itself, the list class, okay? All right, cool. So that PowerPoint was up on eCentennial, and now let's get to it. I want to give you some examples of our list. I want to create our structure, and I'm going to run with this structure next day. We're going to have a lab on Thursday. That's going to be using the stuff we're going to build today, as well as other stuff we're going to do, right? So here's how we do it. We're going to make a new project. We're going to move away from the superhero and supervillain and all that stuff because that was boring. We kind of did as much as I wanted to do with that stuff for now, right? But let's make this new thing. And here's my idea. I want to create a card shuffling and a card dealing simulation. All right. So here's my, excuse me, COMP123. It's the summer 2017 semester, and it's lesson 11. You guys are the B class. And I want to add it to my Git repository here and press OK. Excuse me. All right, so while this thing is going, I'm going to talk about what I want to do, right? So I want to create this. This card shuffling application, and the way it's going to work is this. I want to create a deck of cards, and the deck of cards is going to have a bunch of cards inside of them in the deck. And then I want to be able to shuffle the cards and then deal the top card from the deck, okay? And it's going to be a random card that I'm going to pick because after I've shuffled it, the deck is going to be all randomized. And I can shuffle as many times as I want, and I can deal random cards, and they're going to have values. They're going to have a face and a suit, okay? For now, though, before we do any of that, I want to start off by, in my solution, using a new object, right, which is my class diagram, right? So I'm going to go new. And I want to add a class diagram. That's where I'm going to start off. So I'm going to go here, class, here's diagram. How about diagram? I'll be okay. Hey. Okay, here's my class diagram. That's pretty funny. It's empty. And what I'm going to do is I'm going to go to my Team Explorer for now. I'm going to go to Changes. I'm going to go First Commit. By the way, you can say First Commit or Initial Commit whenever you first start off. And I'm going to go to Home. And I'm going to go to Sync. And I'm going to publish to GitHub for you guys. I'm going to put it on the right GitHub account, which is Centennial. And we're going to call it COMP123 Summer 2017 Lesson 11B. And I'm going to publish. And now you're going to have the first shell of my application online. Yay, fantastic. So what am I talking about? What is this card application and how do I want to start? Well, I want your help. Help me out. What should I do? I want to have a card class, obviously. I'm going to have a deck class, probably, right? But do I start with my card, my deck? I have a suit. Who, by the way, anyone not know how to play cards, never played cards in their life? It's okay if you haven't done it. Some people haven't. So there are 4 suits, right, inside the cards, right? There are clubs, spades, diamonds, and hearts, right? Clubs, spades, diamonds, and hearts. Those are the things that the cards look like, right? Suit has 13 cards. It starts like this: Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, right? So I've got faces, which is what I just said, Ace to King, and I got suits, which is diamonds, clubs, and so on, right? So what do I start? Do I start with the suits first, the cards first, the deck first? Where do I start? How do I code? Anyone have an idea? What would you do? What would you do in the back? How would you start? Any idea? Yeah, I'm looking at you. You have no idea? How about you? What would you do?
I wasn't even listening.
Come on. Right? Well, I'm going to start with a set of enumerations, okay? Because when I think about it, when I want to make my class, my card, I think about ways of cycling through each of the objects, right? And in my mind, I'm thinking, I want to have a friendly name for talking about the faces and the suits, right? So I'm going to create an enumeration. Now, if you guys have never done enumerations, hopefully you have. It's an enum, right? And my enum is going to be, the first one is going to be called suit. Okay? Here's my suit enum. And what I'm going to use this time is the class details object down here. This is just a little tab on the bottom, class details. You can also right-click and go class details, right? And what I want to do here in class details is I want to start adding some members, enumeration members, right? These are enumerables, if you will, okay? So the first one is going to be clubs, right? The second one is going to be called diamonds. Hearts. By the way, there's no particular order I'm putting them in. And the last one will be spades. That's what they're going to be. These are different suits. Think about them as different sets. So there's 4 sets of cards, right? And they have clubs, diamonds, hearts, and spades. For those people who've never played cards before, and there are people in the class who've never played them, okay, if I look at card suits, give you an idea of what they look like, right? Let's get some images going from our friend Google. That's what they look like, right? Spades, hearts, diamonds, and clubs, okay? So that's what we have here. I want to do the same thing, right? By the way, for this enumeration, if I double click on it, and if I hover over clubs, notice that in the background, clubs is actually an integer of 0, right? And the same thing goes with diamonds and hearts and spades. They're all integers in ascending order from 0 to 3, okay? That's, yes, but you can, but basically what I want you to think about them is a friendly name of assigning a value. So instead of giving a value of 0 to 3 for my card, for my suit, I want to give a friendly name, clubs. And in the system, clubs is going to mean, right? So it's more value to us, okay? Let's do the same thing with our other enumeration, right? Now this is a longer one, so hear me out, right? It's going to be called face, okay? And the face enumeration, I'm just going to go here again, is going to start with ace. Now, some people may want to start it with 2, depending on the kind of card game you're going to make. I'm making one that starts with ace is 1. And what I can do is actually assign a value here by default. I can say ace is 1, right? And then I can go, I'm going to start typing them. So 2, right? 3, 4, 5, and so on. Bear with me while I do this so you understand what I'm doing. Here's my enumeration. And the enumeration, what it does is it allows me to, I can actually loop through stuff, right? With having some friendly names. Okay, cool. So there it is. So ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, right? That's my enumeration. That's what it looks like, right? But the great thing is, if I hover over ace, it starts with 1 because I set the value of 1. And if I hover over 2 inside the enumeration, here's my enumeration. So here's ace is equal to 1. Notice that there's an equal sign. I can start the enumerator, instead of counting at 0, I can start it at 1, right? So ace is 1. And then look, if I hover over 2, it's 2. 3 is 3. 4 is 4. 5 is 5, and so on. And king is 13. That means I have 13 cards in every set. I have 4 sets. I have 52 cards. So I'm going to make a deck of 52 cards, and this is the way I'm going to start with these 2 enumerations. Now, has anyone not used enumerations before? If you haven't, it's okay. I'm just telling you this is what I would do if it was me programming this. Now, you might think about it in a different way, and that's totally cool. But that's why we're together. We're together so I can share the stuff that I would do with you. All right, I'm missing a couple things. One is I'm definitely missing some comments, right, from my name, right? I want you to put your name in there. And the date, which is today, July 25th, I can't believe it, 2017. And kind of a description, right, which is a demo. This is a demo for lesson 11, right? And then version, which is 0.1, which is created created the project. That's what this is. I might have put something different in the first class. Okay, cool. And you know what? This is good, fantastic, but I want to take this and I also want to put it in the faces, right? Because each one of these can have its own, right? So this is the face enum, right? That's what it is. And I'll say created the face enum, right? That's what this is. And then I'll take the same thing and I'll put it in my suits. And this is the suit enum. And I created it. That's what the first thing I did here. That's great. I'm going to go changes. And let's say I'll say something like created the face and suit enums. That's what I've done. Commit all. And I'm going to go home, sync, and push. And then clickety-click, you have it on GitHub. All right, so if you missed it or if I went too fast, if yours is not like mine, you go look in GitHub. Okay, cool. So I've got my class diagram, and I got these 2 things. The great thing about class diagram is I can move these around, and I can shrink them up because they're just going to be there, so I can see that I have 2 enumerations, right? The next step is me making my card, okay? This is all so far easy, all right? And my card is going to be a new class, right? So I'm going to make a new class, which we're going to call card, right? And in my card class, I'm going to have a couple of things. First, let's make my comments here, right? So this is the card class. And created the card class. And inside my card class, I'm not going to put a little comment here for the class type this time around. I want to start thinking about private instance variables and, of course, my public properties, as well as my constructors. What else should be? What's next? You guys should know what to do this now. My private methods, right? Come on, you guys should all know this stuff, right? And my public methods. Just some kind of structure to your code, okay? Doesn't have to be pretty, doesn't have to be perfect, but it has to be some kind of structure, some organization where you pass something to somebody else and that they can understand what your code is looking like. Okay, cool. So, and this is just my structure. So what is this card thing going to have? Well, I want to have two private instance variables, right? One of them is going to be of type. First of all, they're private. Type. Come on, give me the type. Face. It's going to be called face. And the other one is going to be of type suit, and it's going to be suit. And you're going to be, wait, whoa, Tom, what are you doing? There is no face type. You're right. That's the answer. There is no face type. It's an enumeration. But I want you to think of enumerations as integers. In the back end, they're integers. They're a special type of integer, all right, in your mind. They're actually more than that, but I want you to think about them as integers, all right? So that's what these are. And now I want to make some public properties. Okay, cool. So up, face. Okay, this is where it's going to get weird, right? Face. How does it know? How does C# know what the hell I want, right? Because I've got the same name, right? Well, because face, notice face is kind of green here, and suit's green, and this is green, this is white. Well, it knows that face, what I'm really doing is I'm calling upon a type, right? And face is going to be the local property that I'm making for my class property, right? Now my get is just the same as always, right? So my getter is going to return this dot underscore face. There's nothing new, guys. You should know how to do this. You should be able to race ahead of me to do this now. Race. Because you know what I'm going to do next. You should know what I'm going to do, right? Which is this dot underscore face is equal to value, right? That's what this does. And I'm going to do the same thing with suit. Yeah, let's do the suit. So I'm going to go public. So here's my prop. And this is suit. It's going to be called suit. It's going to be the only weird thing we're doing here so far. And I'm going to do the same thing. All right, so let's try and see if I can race to do this faster than you. Return this dot underscore suit. And here I'm going to this dot underscore suit is equal to value. Oh, there we go. So that's pretty cool, right? So I've got a couple properties, a couple of instance variables, nothing new, right? Except for the enumeration type. That's weird. And then my constructor. My constructor is going to be public. It's going to be called card, right? And it's going to take two values, right? Watch this. Face, right? Face. Suit, right? Again, I'm using the enumerations as if they're data types. They're not. They're integers, right? In most ways. And this dot face, capital F, is equal to face. And this dot suit is equal to suit. That kind of, kind of initializes their values. And we're just going to put some comments in here. This is the main constructor. It takes two parameters or arguments, which is one, which is a face, of type face, and a suit, which is a type suit. Okay. Anything new here? No. You've seen this again. The only difference is it's enum type, enumeration, as opposed to data type, like an integer or a string or something else. Okay, that's the only difference that these things are. And if I hover over it, you can see that that's what they are, right? And you can see what these are. All right, cool. So that's good. We've done our card class. And let's put this up on GitHub. So we're going to go back to Team Explorer, Home. We're going to go to Changes. We're going to say Added Card Class. Right? At all. We're going to go to Home. And we're going to go Sync and Push. So you guys have what I have. Cool. Card class is created. Let's take a look at the diagram. It's pretty cool, right? But we want to kind of extend with this button here, display the full signature, and extend it so you can see the whole thing. There it is. And you can see that I have one method right now, which is the constructor method. But you know what? I really don't want to see this whole thing, so I'm just going to minimize it. So I'm going to have other things in my class diagram today. Yay. So we've done our suits and faces and cards. And now, my friends, comes the confusing parts. That was the easy parts. So here's where I want to go. This is my thinking. So hear me out. I'm the senior developer, and I'm coming over to you, and I'm saying to you, hey, look, I want to create this deck class, but I want the deck to be a list of card type. Okay, and I said it slow so you can absorb what I'm saying, right? In your mind, you should automatically say to yourself, okay, cool. He's making a class. He's inheriting from type list, which is a generic. And I'm going to make the list a type of card list. How would I code such a thing? Well, it would look like this. So when I go add, new class, right? We're going to call it deck. Now, could you do this differently? Hell yeah. Would you do it differently? Don't know. Well, first, I would put it in here. I'm going to put this as this is the deck class, and this is me creating the deck class, And my deck class, I want you to think what it does. It inherits, that's what I want to do, from the list generic type and uses card as the base type. Okay, cool. That's cool. What do I mean by that? It does this. Watch. Deck inherits from list of type card. Whoa, what the heck did I just do? What is this crazy thing I've just created? Well, I want you to think about deck like it is a list of type card, right? Deck is a card list. That's what I want you to think in your head. When you read this, deck extends the list generic, and the type of the list I'm making is a card list, which I just defined a card. So I'm not inheriting from card, right? I'm composing, again, object or class composition by using the card object as a type for my list. Cool, cool. Okay, good. Let's do the next part. Well, we know that it can probably have things like private instance variables. I'm not sure if I'm going to have any right now, but we probably will. And maybe some public properties. And you know what? We're probably going to have a constructor, maybe some private methods, and probably some public methods. You guys should do this all the time, right? Or something like this. Anyway, yes, we know that. But right now, what can my deck do, right? Well, let me take a look at my class diagram here, right? Well, this is cool. It looks like it's empty right now, right? But what is it really doing? Is it really empty? What I've just done is made a monster. What do I mean by that? Well, take a look at this. If I right-click on my diagram here on my deck and go to Show Base Class, bam, this is the base class for this puppy, right? So here's this deck class. Here's my base class, which is the list type, right? And if I extend it like I want to, right? Let's open her up. And if I do one of these, whoa, this is my list class. And guess what? Because I'm inheriting all of this stuff, including all of these interfaces, right, are all part of my deck class. That means my deck already has functionality. It can do everything that a list class can do, a list with a specific type, in this case, card, right? That means I can add to the list. I can do everything inside the list itself. And I want you to get a picture of this in your head, because if you think when I inherit the list that I get nothing, I get a lot. Okay, does that make sense? I don't need this picture. I wanted it for you. I'm just going to delete it. I'm going to remove it from the diagram, right? For me, for now, my diagram only has a little deck, and it doesn't have anything inside of it. Okay, cool. So here's what I want to do. When I build my deck, when I instantiate an object of type deck, I want to immediately create a list. All our objects inside the list. My deck can't be empty. There's no such thing as that in real life. When I have a deck, it's full of cards. There's 52 cards inside of it. So when I first create my deck, that means in my constructor, I want to somehow build my deck immediately. Okay? So let's do that. So I need a constructor. I don't need to take any variables right now, so no parameters. So just like this. But I want to call, I don't have this yet, but my initialize method, right? Remember I talked about this? I said in your initialize method, you probably want to do some stuff like initialize your instance variables and so on. Well, that's what I want to do here. So inside of my private method, I want to make a new private method called initialize, which returns void, by the way. There it is, right? And what I want to do is I want to, in my initialize method, I want to create all my cards. I want to add all my cards to the list, right? Okay, whoa, wait a minute. What the hell am I talking about? What list am I adding the cards to? Let's go there first. Come on, what list am I adding the cards to? How do I add cards to the deck itself? How would I do that? What would be the command to do that? Think about it. Remember, the deck is a, there's no deck. We're just instantiate. We're making a deck now. So how would I do it? What's the keyword that I need? How about this? Dot add. It is a list, right? This thing is a list. I can add it. This is the container. This deck is the container for my cards, right? So I can do this. So this dot add, and I can add in a card type, right? So I can do something like this. I want to add a new card, right? Oh, I hate when it does that. And my new card, right, which I'm adding to the list, is going to have two properties, right? It's going to have the face and the suit. But I don't have a face and suit yet. Look, face and suit. I'm just building up the way I'm going to build up my algorithm here, right? Okay, cool. So that means I need some for loops, right? I'm gonna cycle through my suits, right, through a number of faces until I have enough numbers to change these things and add them into my deck, right? So what do I mean by that? I need a for loop. Let's try the for loop. Let's see if I can make the for loop. All right, cool. So it's the outer for loop is going to be the suits, right? I'm going to call it suit. And it's going to be, okay, this is interesting. Here's suit, but it's not going to be of length. Wouldn't it be of the suit itself? Can I just do this? I want to go, well, I want to look at the suit dot spades, because spades is my last value. I can go suit dot spades, right? What does that mean? And why is it giving me an error? Well, it is an integer, but it wants me to cast it as such. I want to do something like this, yeah? Take a look. So this outer for loop is going to take a look at the number of my enumeration. My enumeration spades, if you look at my suit, it's the last value. Club, diamonds, hearts, and spades. Spades is 3. So instead of me saying spades, right, or 3, it's a nice friendlier way of saying 3. Spades. I want to go from clubs to spades. That's what I want to do, right? Okay, cool. But that means I won't include spades, right? And earlier today, we kind of figured out that we're going to do a less than or equal to because we want to include spades, right? If I put less than, it will never get to spades. So I need to do a less than or equal to. Well, if that's true, then I can do the same for loop, right? My inner for loop is going to be for faces. So I'm going to say this is going to be called face. And my length, right, is going to be the same thing we did up there. I'm going to say int face dot, and notice I have access to all my faces, and I want to go to the last face, which is king, right? So I want to say where it's less than or equal to king, right? Because king is my largest valued face, right? Face, king, 13, right? So I want to go from not like up to and including spades and up to it including king. I want to take those values, and now all I have to do is take this, cut it, and put it in the middle. And there, my friends, I'm loading my suit full. But here's a problem, right? Here I'm returning integers, but what I really need is and suits. I'm casting. I'm casting one way and I'm casting the other. Now there's other ways to do this, by the way. And casting costs a little bit of performance, but for now, this will be fine. Okay, so anyone not understand what I've done here in my initializer function? So what I'm doing is I'm cycling through, right? And as I cycle through all of my, I'm adding a card. I'm adding 52 cards to my deck, right? One card at a time. And I'm cycling between suits and faces. So I start off with, I don't know, for example, the first one would be suits. The first suit would be clubs. And the first face would be ace. So the first thing would be ace of clubs. And I'm going to keep doing that. Ace of clubs, two of diamonds, and so on. Now I want to print them out. I want to test this theory that I have, that this works, right? So down inside my public methods, I'm going to add a new public method called, which I'm going to override, which would be which one? The toString method, right? And if you press Control space, you can see that my toString method will come up. I'm going to override this toString method. I'm going to create a new string, which is the output string, which I'm going to initialize to this again, right? The null string. And then I'm going to go like this. I'm going to say, well, you know, for each, right? I'm going to do the for each loop, right? Here's the for each loop. For each card, right? That's what I want. For each card in my collection, oh man, what collection am I referring to? What do I put here? Where I'm going to loop through, but I don't know what to put in there. I'm in trouble. How can I loop through my collection? But my deck is the collection. So what do I put there? This is all I put there because this is the collection, peoples. Right? I'm looping through remember, my deck is a collection, right? It's a container that holds everything, right? So now I'm going to do something like this. So for each card, I want to say my output string is plus equal to, I want to say the blank, right? Which is card dot face plus of plus card dot suit plus and then backslash n. What's this going to do? The ace of spades, the two of spades, the three of spades. That's what's going to output, right? That's my output string, and I need to return that at the end. Return output string. Okay, let's document everything and put it up on GitHub for you. So first, I need to document my constructor, right? My constructor is the empty constructor. So this is the main constructor, right? And in here, this is my initializer method, right? I'll say // this is the initializer method. It sets values for private and public variables, private variables, and public properties. I need to, as well as other class objects, right? Someone's got a call when I'm teaching. Someone's got it. Okay. That's what this does. And here's my my override string methods, which I'm going to do something like this. I'm going to say, again, // this is this method overrides the built-in toString method and returns. Actually, we'll do the return of the returns. How about that? To make it different this time around. Returns. This method returns a list or the the current cards in the deck. Okay. This method returns the current cards in the deck. All right, that's pretty cool, right? That's what this does. Method returns the current cards in the deck, right? And let's test this out. Let's see if it works. I'm also going to put it in my program class. I'm going to make 0.2. I'm going to say we're going to implement the deck class. How do I implement this thing? Implemented the deck class. I implemented the /test. The deck class. And down in here, I'm going to do that. I'm going to say deck is equal to new deck. Yeah? Oop. I love when it does that. And I want to say console write line deck.toString. Right? And that should print out my deck. Okay, let's test it and I'll put it up on GitHub. So test. Yay! That's what you should get to. So let's check to see if it's all right. So the 0 of clubs. Huh? What? What did I do wrong? I did, right? And I can't do that. Let's go back. So if I go to suits, so let me go back. So let me show you what I'm talking about here. So here's my deck class. And here, there's also a problem, right? It goes from suit 0 to suit of spades. There's no such thing as that. It goes from, so suit starts at a number, right? So what does the suit start at, right? Suit. So suit dot clubs, I believe it's clubs we start off, and goes to suit spades. That's the first thing. Now this is weird, right? Can't start at 0. It's got to start at ace. Right? So it starts off at ace and goes to face.king. Make sense? Let's try it again. And now, my friends, we have everything we want. We go from ace of clubs 2, 3, 4, 5, 6, all the way to king, and then repeat for each of the suits. And now we've done what we wanted to do. We're going to take a short break, but we've done everything we want. We've loaded up our deck with cards, right? And now I'll put it up on GitHub. So I'm going to go to Team Explorer. I'm going to go to Home, right? Changes. I'm going to say created deck class. And we're going to say commit all, Home, sync, and push. There you go. Let's take a short break. And when we come back, I want to do this. When we come back, I want to create a shuffling algorithm. I want to take the cards that I have and move them in random places. Random. Yeah, which is going to be interesting. Let's do that. And if we can get that done, that'd be really, really happy. All right. It took us pretty much the rest of the second half of our time to get to do that. So let's take a short break and we come back. Let's say 5 minutes for a washroom and water break. And we come back, we'll do the rest.